if the first and the nth term of a GP are A and B respectively, if P is the product of n terms, okay, prove that P square is equal to AB whole to the power of n. So it is of importance to us for us to write whatever is given in a neat manner. So first we have the first term and we have the last term to be B, and we have the product of terms, the capital P, that is to be first, second, third term, so on and so forth till nth term, right? It's a product of that. So we are looking at to prove we have P square is equal to AB whole to the power of n. Then we have the proof. So we'll start off with, well, we don't have the information of R, we'll assume that. Let's consider the geometric progressions, common ratio to be R. Okay, and then we have a n formula, which is a into r to the power of n minus 1. So with this we can tell, therefore B is equal to a into r to the power of n minus 1. This is one of the things that we can write. So what else? Nothing much, that's it. So let's start off with writing P. So P is equal to a1 into a2 into a3 till an. And then we have first term is a, second term is a into r to the power of 1, third term is a into r square, so on and so forth. An is a into r to the power of n minus 1. All we are doing is substituting, right? We have written the formula and we are substituting over here. Okay, so what else can we do? Well, now it is clear that we have exponential aspect, so we have to make use of e to the power of n into a to the power of m, which is a to the power of n plus m formulas over here. Since everything is getting multiplied, so we have a to the power of 1 plus n terms, is it not? Because there are n terms, there's nothing to discuss about it because this is first, second till nth term. And we have r raised to the power of 1 plus 2 plus 3 plus n minus 1 term. Okay, because the first term will not have rth power, right? R starts with 0 for the first term. So this also, let me change the representation. So this is 1 plus 1 plus 1 plus n terms. Is it not? So this is n terms and this is n plus 1. Okay, so 1 plus 1 plus 1 n terms, what will be the answer? Right, this will be n clearly, is it not? So this will be n, my bad. So the first term will be n, but the second term, let us solve the second term actually. So what is 1 plus 2 plus 3 plus n minus 1? This is clearly a sum of natural number. We have a direct formula for that. If you guys don't remember that, we can make use of AP formula. That is Sn is equal to n by 2 into 2a plus n minus 1 into d. Again, this is a long shot. If you guys don't remember the formula, this we have to do it. So here n is n minus 1 because there are n minus 1 terms. And the first term is 1. And we can actually make use of this formula rather than this. A plus an. So the first term is 1 and the last term is n minus 1. Right? So all of this put together, it is n minus 1 into n by 2. Again, if you guys don't know the formula of sum of natural numbers, n natural numbers, this is the way to go about. And finally, we have a to the power of n into r to the power of, and remember this is p by the way, r to the power of n into n minus 1, this entire thing divided by 2. So with this on hand, let's take the LHS. LHS is the p square. So basically we have to square this. So this is nothing but square of this and squaring this. So what happens over here? We have this 2 and this 2 getting cancelled, and we have this is a to the power of 2n into r to the power of n into n minus 1. Okay, so let's look at RHS. What is that we have? We have ab whole to the power of n. So let's take n common. Again, we have written all these formulas, the related formulas previously, so you don't have to mention it again. So I can remove the power of n, and we have the following things to be left out. And inside the brackets we have, right, inside the brackets we have a into r to the power of n minus 1 to the power of n. So this is nothing but your first term, and this is nothing but your last term, is it not? So we pretty much got the answer. So this is nothing but a into b whole to the power of n, this is p square, and we have the RHS, and so we have proved the question. Okay, so literally I didn't do anything fancy. All I did was follow what was given, rearrange the terms, right? So again I'll just mention this is to the power of, so this is the easier representation when we are dealing with long expression, and a bit of simplification and a bit of arithmetic progression, and then looking at what is required for the question. So p square, so I squared, again a bit of simplification and a bit of exponential formula, and here is a bit of looking at what is required again. And when I wrote that I needed a out of a square, so it will be a into a, and r to the power of n minus 1, this is clearly b, right? And so we have the RHS.